Hello students, welcome to RD Chemistry. Here we'll see the concept of line spectrum of hydrogen. You know that in the line spectrum hydrogen, we have got mainly 5 types of series: Lyman series, Balmer series, Paschen series, bracket series, and Fund series. Right? How to find out the wave number or the wavelength of these lines or these series? We have the formula to find out the wave number, which is nu bar is equal to 1 by lambda. Lambda stands for the wavelength, is equal to the Rydberg constant into 1 by n1 square minus 1 by n2 square into the atomic number z square for any other element containing one electron. Okay. Now, what is the n1 and n2? n1 and n2 are the integers. n2 is always greater than n1. Lyman series, n1 is equal to 1, Balmer 2, Paschen 3, bracket 4, Fund 5. And see the regions here. Lyman series belongs to the visible region, UV region. Balmer series belongs to the visible region. Rest 3 belongs to the infrared radiations. Problems on this can be asked. So remember the formula here. Remember as a note, the maximum number of spectral lines possible when an electron returns to the ground state from the nth orbit, from higher level nth orbit to the ground state, n is equal to 1. The formula is, it is n into n minus 1 divided by 2. Okay. We'll solve one question. The wave number of first line in the Balmer series of hydrogen is 15,200 centimeter inverse. What will be the wave number of the first line in the Lyman series of beryllium plus 3 ion? How to calculate wave number? Wave number nu bar is equal to Rydberg constant R into 1 by n1 square minus 1 by n2 square into the z square. This is a beryllium now, the given, right? We have to calculate for beryllium. Hydrogen, helium, lithium, beryllium. Atomic number Z is equal to 4, right? The first Lyman series. For Lyman series, n1 is equal to 1, fixed. When they say first line is jumping of the electron from second orbit to the first. Second line means third to 1. Okay, second line is third to 1. This is the first line, the second line. They are asking for the first line. So jumping from n2 to n1. Rydberg constant R is equal to 1.096 into 10 power 7 in terms of meter inverse. Or R is equal to 1.096 into 10 power 5 centimeter inverse. You have to remember this, students. Okay. Options are not given here. We can find the answer in terms of meter inverse or centimeter inverse. So I'll go for centimeter inverse, the value R. So wave number nu bar is equal to 1.096 into 10 to the power 5 into 1 by 1 square minus 1 by 2 square into the atomic number, that would be the 4 square. This is equal to 1.096 into 10 power 5 into 1 by 1 minus 1 by 4, and this is the 16. On simplification, we get this as the about 1.3 into 10 power 6 centimeter inverse. Okay, right? Clear? Remember, student, in this question data, okay, because we already know the value of Rydberg constant R. Otherwise, we would have made two equations. then take one equation divided by second equation, those common term r get cancels. Now this is a straightforward question here. Here goes the second question. What electron transition helium plus 1 spectrum would have the same wavelength as the first Lyman transition of the hydrogen? I'll write for this one now. 1 by nu bar is equal to the wavelength. So I need to have 1 by lambda of the hydrogen is equal to R Rydberg constant into, I'll write the formula, n1 square minus 1 by n2 square into z square. Correct? So 1 by lambda h is equal to R into 1 by 1 square minus 1 by 2 square, right? Like previous problem, into hydrogen spectrum z is equal to 1 square, right? Now we'll take the helium plus 1. For helium, atomic number z is equal to 1 by lambda of the helium plus is equal to r value is a common term into, we do not know the transitions in the helium, let it be n1 square minus 1 by n2 square into this z square is equal to 4 now. Question is, would have the same wavelength. So we'll equate these two terms now. Either lambdas are equal or 1 by lambdas are equal to each other, right? So I'll directly make them equal to each other. R is a common term, get cancels, right? So this is a 1 by 1 minus 1 by 4 it is equal to 1 by n1 square minus 1 by n2 square into 4, correct? Sorry, into 4, or simplification of this one, 4, this is will be n1 square minus 1 by n2 square into 4, right? Or I'll simplify further, 3 by 4 into 4 it will be is equal to 1 by n1 square minus 1 by n2 square, correct? Or finally 1 by n1 square minus 1 by n2 square is equal to 3 divided by 16. We do not know the value of n1 and n2 here. Okay. If they give the MCQs options, in the option there will be numbers will be there. N1 is equal to so much, N2 is equal to so much, 4 options. Now, which option will give you this number 3 by 16? Okay. So I'll give the answer here directly. Suppose I have got N1 is equal to 2 and N2 is equal to 4. Then it is 1 by 2 square minus 1 by the 4 square is equal to 1 divided by 4 minus 1 divided by 16 is equal to, this will be 16, this is equal to 4 minus 1, therefore it is equal to 3 by 16, correct? Yeah. So if they give the option, you can try those numbers. Okay, clear? Hope this is clear to you. Do like, share and subscribe RD Chemistry. Thank you for watching.